shape is a parallelogram. So, quick review of all of our properties of parallelograms. Opposite sides are parallel. You need to have both pairs to prove it's quadrilateral. So we gotta have these parallel and these parallel. So you need both in order to say it's parallelogram. We also know opposite sides are congruent. Again, you need both. Those two are congruent, and those two are congruent. So this both part is like a huge dealio. We also know stuff about angles. We know that angles that are next to each other add up to how much? 180. How about angles that are opposite each other? They're the same. Again, you need both pair of opposite angles to be congruent in order to say it's a parallelogram. Diagonals, remember those are your lines inside our shape. Those bisect each other, and what's it mean to bisect? Cut in half, yeah. So these halves are the same, like this and the same as this, but those aren't the same as these two, okay? The green ones are equal and the blue ones are equal to each other, but the blue is not equal to the green. Does that make sense? Okay. And then this is the only new thing to prove that a quadrilateral is a parallelogram. You can take one pair of opposite sides, and they have to be both parallel and congruent. So you either need to prove both opposite sides are parallel, both opposite sides are congruent, or one pair is parallel and congruent. Okay? So those are our different options for proving that four-sided shapes are parallelograms. So, if I look at this first one, can I say I have a parallelogram? Why? Yeah, and that keyword both. So both opposite sides are congruent. In my next one, can I say I have a parallelogram? Opposite sides? Angles. Okay, how many pairs of opposite angles do I need? You need both pair of opposite angles. Do I have both pair of opposite angles?
No.
No. So can I say this is a parallelogram?
No.
No. Only one pair.
You say the one below it is then?
Yeah. You want to do that one now? How about we wait for a sec? How about this one on the left? Yeah, why? Diagonals do what?
Bisect each other.
Bisect each other. What if I just had one of them? No, you need both. You need both diagonals to bisect each other. Alright, how about this next one? What do we think? Yeah, because now we have both pair of opposite angles are congruent. So does that difference make sense between those two? So you need both of them in order to say that they are congruent. How about the one on my left? Yeah, what do I got going on there? Both opposite sides are parallel. How about the next one?
Yeah.
Yes.
Parallel and congruent.
Yeah, this is that one weird one. There is one pair of opposite sides that are both parallel congruent. If we would have just had like these are parallel and these are congruent, so like not had those, that's not the same thing. Okay, you need the same lines to be both parallel and congruent. Alright, I think we got two more, yeah. What about this one? What's going on here? I have vertical angles. Does that mean I have a parallelogram? No. This doesn't prove anything. I don't remember what the first question was. What did it say? But we'll just go with no. That's fine. No. Trickiest one. Right here. Why you say it's yes just because I said it was tricky?
It kind of looks like it'd be a yes.
It just looks like a yes.
Because of the opposite angle.
What about my opposite angles?
Those are alternate interior.
Yes, alternate interior angles mean that I have what kind of lines? Not congruent. Parallel,
I
yes.
said that the first one.
So the
Yeah.
alternate interior angles means these lines are parallel and these lines are parallel. So now that I have those labeled, do I have a parallelogram?
Yes.
Yes. Because both opposite sides are parallel. Alright, how are we doing so far? Fantastic. Alright, last page. Yeah, see, I told you it wasn't that bad.
First day of it.
I said Dave.
Oh. Alright, we gotta find x and y to make this a parallelogram. First off, can I solve when there's two variables in the same equation?
No.
No, so like can I work with opposite angles?
No.
No, because I got y's and x's, okay? If I look at, yeah, both my x's, they're next to each other, which means I have to add up to 180, okay?
Just set them equal.
Yeah, so add them up to equal 180. Good. So I'm going to take this 4x plus 13 plus that 12x plus 7, and that has to be 180. How much total x do I have?
16.
16x plus 20 equals 180. Subtract your 20, we get 160, so x is 10. Yeah, you have a couple options with this next one. We can do the same thing because we know that those add up to 180. Or if you wanted to, you could plug in for x, find out what your opposites are, and solve from there. What do you guys want to do? Which one?
Same thing we did.
Same thing we did? Okay. Alright, so the y's we know add up to 180. So I got, can I just total them? Is that okay? 4y plus 8 has to equal 180. Subtract your 8, 172. And I have no idea what that is. What do we get? 43. Sweet. Questions are? Alright. It says, can you prove that I have a parallelogram based on the information? What theorem can we use? Theorem is just like kind of walking through like opposite sides are equal or all that stuff. Yeah, she's done in health.
Do you think she'd care if I cut all that laminated stuff? I mean, there were kids taking tests and I got nothing to do.
No. Do it.
Okay. Then don't tell her who did it and she'll never.
Okay. I'll tell her I did it. I'll take all the credit. Yeah. Alright, it tells me AE equals CE equals 14. All that means, I'm not going to ever seen that, but it just means that AE is 14 and CE is 14. Okay? And then it also says that DB is 2 times DE. So DB, this whole line, is twice what DE is. So like if this is X,
That's a midpoint.
yeah. So if this is X, this is X, which means that these, because that's 2X, right, total? So that means that these are equal, right? So given that the greens are equal and the reds are equal, can I say I have a parallelogram?
Yes.
Yes. Because what do I got going on? Yeah, the diagonals bisect each other. Good. Like, I know you guys are used to having like theorems or like side angle side or whatever. I'm not too worried about what they're like technically called. It's like more so, can you explain what's going on? All right, one more. Let's label our picture. It says we got y is 49. It says z is 131 and w is 49. How am I going to prove that I have a parallelogram? Can I prove it? Opposite angles, okay. But I'm missing an angle.
They equal 360.
So is 360
No, that's
specific to a parallelogram, or is that just all quadrilaterals?
All quadrilaterals.
Yeah,
Yeah, they have to equal 360.
but that's all four-sided shapes. So parallelograms, we have a couple things about angles. We have opposite angles are equal, and we also have the angles next to each other add up to 180. So if you're gonna use the 180 thing to solve that angle, you might as well just use the supplementary in general. Because what do those angles add up to? 180. What do these angles add up to? So is it true that adjacent angles are supplementary? Yeah. So do I have a parallelogram?
Yes.
Yeah. Adjacent angles are supplementary. If you wanted to solve for this one with the 180 stuff, that's fine. And then you could say opposite angles are equal. You're just basically doing the same thing. Alright, questions?